All right, guys, how do we find volume? Integrate area. That's it. Okay? So every volume problem, how do you find volume? You integrate area of the cross-section. Okay? I used to get frustrated on these type of problems because I was always trying to visualize what the 3D solid looked like. Is it fun to like, oh, this is what it looks like? Sure. But is it necessary? No. Okay? So there's 2 questions you ask yourself. Okay? Anytime you're dealing with volume in calculus. What is the shape of the cross-section? And then what is its formula for area in terms of x or y? Okay? Now, the reason we need to know the shape of the cross-section is so that we can generate the formula for its area. There's been a couple times, I can remember in 2009. Sounds like yesterday to me. For you guys, it's like we weren't even born. Oh, cute. Where they gave them the area. The area of the cross-section, it was like, you got this 3D solid, the area of the cross-section as a function of x is a sine of pi times x. And the kids were like, wait, what's the shape of the cross-section? Oh my gosh, they didn't tell us the shape. They were all in a panic. Okay, well, if they give you the area, you skip that step, right? So, how do you find volume? You integrate area. So what's the shape of the area? And then you generate the formula for its area in terms of x or y. Okay? All right, so first one was just like finding area between 2 curves, top minus bottom with respect to x. Yes? All right, so square cross-sections. Okay, fingers crossed you get square cross-sections, right? My prediction is it'll be semicircles. I've told you that story, right? I say that every year. I've been wrong, but one year I'm going to be right, and my kids are going to be like, how did you know? I just knew. Okay. All right, so it hasn't been semicircles in a very long time. All right, so squares. Square cross-sections. You pay attention to perpendicular to the x-axis, perpendicular to the y-axis. So perpendicular to the x-axis means it's a dx situation. So what is the shape of the cross-section? Square. And then I generate its formula in terms of x. Okay. And if we didn't have a grid, okay, if we didn't have a graph that was gridded, if we weren't using a calculator, how would we find those limits? How do I know where to start this accumulation of volume and stop this accumulation of volume? How did you find these values here? Because they were intersected at nice lattice points? Okay, where they equal each other, how do I find where 2 functions equal each other? Set them equal to each other, solve for x, points of intersection. Okay. So for square cross-sections, they don't have to give you either dimension, right? So you've got to, I always draw. I have to come off to the side and say, you don't care if I draw, let me just see. Okay, so I've got these square cross-sections sitting perpendicular to the x-axis. Where's your fun foam cutouts?
See, the problem was I made the big ones.
They are big.
For the big picture.
Oh, nice. So.
Here's my small square. I only made the square small because I was frustrated by that one.
I need to make some new ones. Okay, so it says square cross-sections perpendicular to the x-axis. So I got these square cross-sections coming out of the board, yes? And you can see when I put this square right there, do you see that the thickness, okay? We're technically finding volume, right? So this dimension times this dimension times this third dimension. And if I set this right here, you can see that third dimension is some tiny little dx, right? Some delta x. So that's that third dimension right there, okay? So the area of the cross-section times its thickness. And if it's perpendicular to the x-axis, you can see that that thickness, that third dimension, is dx. Okay? Make sense? So I always think about that. I draw myself one little shape of the cross-section, and I say, okay, so this dimension here is what I have that's sitting between those 2 curves. So top minus bottom, what's the y on top? Minus the y on bottom. And guys, if this were a calculator problem, or a set up but don't evaluate problem, because those are very common when it comes to volume, I'm just going to call the functions by their name. Okay? So if this were a calculator problem, I would integrate. I would start this accumulation at x equals -1, stop our accumulation at x equals 2, and I would do top minus bottom, g of x, minus f of x, that quantity squared with respect to x. Sorry, this is getting really messy. Does that make sense? That way, I wouldn't worry about copying these functions, because if I make a grouping error, then I've lost a point. Okay? All right, so rectangle, yes, yes. You can name them. You can go off to the side and say, let f of x equal this and g of x equal this. Yeah, that's not a thing in calculus. They don't recognize that. So don't do that. So that's one of those things that's like, I wonder if I could do this. So if something like that comes up on the AP exam, like I wonder if this is okay, just don't do it. Like I wonder if I can abbreviate point of inflection as POI, don't do it. Okay. I was at the reading one year when it was still face-to-face in Kansas City. And at lunch, this teacher was like, Mike, I keep reading these papers and it says POI, POI. What's POI? And somebody was like, do you mean point of intersection or point of inflection? And she goes, oh crap. So basically she was not giving kids credit for that. So just be careful, because point of inflection versus point of intersection, right? Okay, so rectangular cross sections. So rectangular, they would have to give you that second dimension. So we've got one dimension sitting here between those two curves, so top minus bottom, and then our height of 1. So there's your one dimension, okay, the base, that height, and then that third dimension, that little thickness, little piece of thickness. Okay, so, all right, so triangles. I have not seen, and I cannot recall a time where they gave us an equilateral triangle cross-section. If they did, I'm pretty sure they would give us the formula for its area in terms of the side. Otherwise, you generate it using Pythagorean theorem, but that's time-consuming and it's so much algebra involved that they probably wouldn't set that expectation. So if it was an equilateral triangle cross-section, they would give you that formula for area, okay, as a function of the side length. Semicircles, do that. Well, like I said, they would give you the formula. Semi-ellipses, they've done that before, but they've given you the formula. An ellipse, semi-ellipse. I doubt that would be. It's going to be semicircles. It's fine. An ellipse. Oh, no, I'm talking about an ellipse. So like, ellipse. Okay, so think about this, guys. Here's a circle, little mini lesson here. Okay, radius is the same, right? Yeah, vertical axis and that horizontal axis. And we just, area is just pi times r times r. So we clean that up to be pi r squared. So here we have major axis, minor axis, your vertical, horizontal, just pi a times b, where they're different. So that's that special case where a and b are the same. But if you're doing a semi-ellipses, it would just be half of that. Again, that would be one where they give you the formula. Haven't seen that since way before you were born. So triangles, if you do see triangle cross-sections, it'll be a isosceles right triangle with a hypotenuse on the base. So the hypotenuse of the triangle is sitting between the two curves. Or an isosceles right triangle with a leg in the base. Okay. That would just be half a square. So, all right, so semicircles, we're good, we're good. All right, where are we at? You want to work this one? All right, this one does say we have a calculator problem. All right, so we've got a region bounded by those two functions, y equals e to the x and the linear function y equals x plus 2. All right, so that two-dimensional region is the base of our solid. Find the volume of a solid whose cross-sections are perpendicular, square cross-sections perpendicular to the y-axis. So this time we have these squares sitting like this. Now do you see when I put this square here, that little thickness, the thickness of this cross-section is covering up a little piece of that y-axis? So as soon as I see that phrase, perpendicular to the y-axis, it's a dy situation, including my limits. So I always remind myself, okay, I've got to accumulate this starting at y equals something, stopping at y equals something. All right, so we've got these square cross-sections. Okay, imagine this coming out of the board. I like to come over here, give myself a little visual of that cross-section, and remind myself that one dimension is what's sitting horizontally between those two curves. All right, so how do I find this horizontal distance? If I'm on a coordinate plane, and I want to find the horizontal distance between these 2 points, what would I need to know? Well, the y, they would have the same y coordinate, right? I would need to know what is the x on the right and the x on the left, right? So I would be subtracting those 2 x coordinates to find that horizontal distance between those 2 points. So that's what I need to know over here. What is the x on the right and what is the x on the left? So we need to come up. We got the relationship between x and y. We just need to solve for x. All right, so if y equals e to the x, what does x equal in terms of y? So I'm solving for x, so I'm doing inverse operations. So natural log base e is the inverse of exponential base e. So take the natural log of both sides. X equals natural log y. We're just solving for x. We're not integrating. All right, and then here, same thing. If I'm solving for x in terms of y, using inverse operations, we just subtract 2, so x equals y minus 2. So over here, the x on the left, natural log y, sorry, x on the right, x on the left, y minus 2. All right, how do we find the area of a square? Good, side squared. All right, so what is the length of that side in terms of y? There you go. We take, yeah, right? So just like I want to find that horizontal distance between those 2 curves. So I need to know what is the x on the right minus the x on the left. So natural log y minus the quantity y minus 2 equals side squared. All right, so what is the, so I asked myself 2 questions. What's the shape of the cross-section? Okay, square cross-sections. And then what is the formula for its area in terms of y? Okay. So I just take that side length, natural log y minus quantity y minus 2, and square it. I could clean it up if I want to, but don't have to. It's a calculator problem. All right, you got your calculators? All right, let's graph this. You can if you want to. It's not the reason I'm graphing this. What do I need to find, guys? What am I missing here? My limits. Let me give myself some more room here. All right, so we know that to find volume, we integrate area. So I'm integrating the area of this squared that we just generated the formula for with respect to y. So everything is in terms of y, including our limits. Mm-hmm. All right, so we're finding those points of intersection. All right, so that's not a nice, friendly number, so what do I need to do? Okay, what am I storing? I would store the y. What are we going to call it? A? That's what I do. Is there another way? Okay. Oh, I don't know. I don't know about that. This is the way I've always done it. So, do I? Okay, hold on. I'll show you how I do it. Intersection, right, left. I just grab it. Touch it, grab it, store variable, and then give it a name, hit enter, make sure it becomes, I stored the wrong one. Y'all see that? And it becomes, oh, I didn't see that. That might have been an accident. Yeah, that is probably an accident. Okay, so I stored the wrong one. So I'm going to grab that, store variable. Am I allowed to call that one B2? No. I don't know. Oh, yeah. It's still connected. Yeah. Okay. So we can call these A and B as long as I write a note to my reader and tell the reader what is A and B. So I'm going to say, let A equal. Let A equal. I'm going to go to a calculator page here. .158 ...
Oh, I've already accepted.
What are you saying? Chemistry was the only AP test I got a 5 on. I didn't get just chemistry. Nope. 146 ... All right, I call this B 3.146 ... Okay, that was my, okay, so that's what I was looking at over here, 3.15, okay? But the reason, before I wrote it on my paper, the reason I went to my calculator page was because I needed to see at least 3 decimal places. Don't tell the reader you're calling it 3.15, because that's called intermediate rounding, okay? And you'll lose a point for that, because you're going to have 1 point just for the limits. Okay? Usually the limits, especially if they're not nice, will be a point in itself, and if you say that that limit is 3.15, that's incorrect. If your calculator doesn't show you more, like this one, we should probably change the settings. Perfect, that's what you want. Okay. No. If yours does this, we should probably fix the setting. Yeah, hers is good. Good, there you go. Maybe it's because when you got a new device. All right, so then at this point, guys, I can punch this in the calculator. Okay, so put another parentheses. Go right there, put a parentheses. Okay. Now I'll try to square. Good?
I don't think when they put in the limits, sure what you're doing.
Ooh, I don't know. I'm not the...
I guess because that's what you're afraid of.
Oh, no. That's just to remind myself not to record X values. Try it though. You can round or truncate. Just write the first 3 numbers you see after the decimal and just cut off everything else. All right, can we confirm that the answer is 1.544 ... No, you can't put 1.54 ... You can't put 1.5 ... But you don't even need the ... here. But typically when I write down my limits, I put the, you want to do it here. You want to tell the reader, hey, I'm not just storing the 3.146. I'm storing that true value. All right, any questions? Can I erase this and say one more? Oh. Okay. Here's something else I'm going to tell you. Okay, because free response questions are like multi-part questions. Let's say in part A, we had to find the area of this region. Okay, so if it says, hey, find the area, and that was part A, then I would have already found these points of intersection, and let's say I stored that as A, okay? And I stored this x coordinate of the point of intersection as B. And then I get to part D of this problem, and now it wants me to do something with respect to x. Do I need to go back to my graph and store those y values? So what could I use as my limits? If I had the x coordinate of this point stored as A and the x coordinate of that point stored as B, what could I use for my limits if I'm now doing a dy situation? There you go. E to the A, e to the B. Or A plus 2, B plus 2. Because both of these points are on both functions. So if I already have the x coordinate, well, here's the relationship between x and y. Okay, so that is legal. Because most of the time these are a setup but don't evaluate. So I wouldn't want to take the time and restore those, write all that down. We already have the x coordinates. Use that relationship. Good? Either one. Mm-hmm. All right. So how do we find volume? Integrate area. Okay, area of the cross-section. What's the shape of the cross-section? And then what is its formula in terms of x or y?
Okay, we're going to do something on our calculator first. It was something that occurred to me yesterday that I said, oh, I'm going to show you all that before the test, but maybe I should show you before the mock test. So I'm going to kind of help you through this. Yes, right? Parts of it, yeah. Okay, no. So y'all are testing with me in here. And then once we're done, so if we're done and we can go to 4th lunch, we will. If we're done and we have a 5th lunch, we'll do that, okay? Then you're going to your regularly scheduled programs. The rest of my classes are not coming to me. They're going to the MMC. but because there's only 9 of y'all and you were 5th period, just come here. If we go to 5th period at all, just come here instead of having to go to the MMC or do whatever. I'm not going to make y'all do any work or whatever, but we can talk about the test and things like that a little bit. We can cry. We're not going to cry. Yes, yes. And I have information about that too. We'll talk about that tomorrow. Just remind me. Okay, so here's what we're going to do. Now, because you have 2 calculator questions, all right? And so let's say that this was FRQ1, right? Now you're going to move on to FRQ2. Well, if you clear all this out and you do your second free response, then you realize, oh dang, this is what I should have done on the first one. You don't want to have to go in and recreate all this again, right? So every time we go and we get a new document, it asks us, do you want to save the old document? And we say no, right? So what we're going to do right now is we're going to create 2 documents, FRQ1, FRQ2, and I'm going to show you how to get to them. That way you can open up, this is the one that I do first, then this is the other one, and then you can go back and forth if you need to. Does that make sense? Okay, so here's what we're going to do. We want document. No, we don't. Say, crap. How do we get a new one? There we go. We want new. So hit your home button, new. And since it said, now read what it says, because we always say no. Do we want to save to unsaved document? The answer is no. If it said, do you want to save FRQ1, because you just did stuff, and your answer is yes. Does that make sense? Okay, so we're going to go no. We're going to add a calculator, and then we're going to add a graph. Oh my gosh. Okay. There we go. What the heck? Y'all know how to do that. Add a pad. Add a graph, right? Okay. So then we want to save this, right? So, save here. See, I don't even remember what I did now. I did this earlier. We're going to go back over here, and we're going to want another new one, and then we want to say yes. So we're going to save the unknown document. We're going to save it in My Documents, and let's just call it FRQ, FRQ1. Everybody with me? Are you on this page? Lorenzo, you look lost. Oy. New document. Do you want to save on, did you already make a new one? Yes. No, it's not. It has graphs in it. Okay, now add calculator and add graph. But that one, okay, maybe you already did. And then we're going to save it. Okay, so now, if you look up here, so we have a new document. So we added I'm going to do add calculator and add graph again. God, what's wrong with me? Add calculator, add graph. We'll do another new one, so it'll ask us if we want to save it. The answer is yes, and we're going to call this one FRQ2. FRQ2. That our calculator. FRQ2, and we're going to save it. Okay? That's what I'm about to show you. No, that's okay. Do we have so this one, if I just add a calculator here, now it just says doc up here at the top, right? But I need to get back. Let me go check on my old people over here that can't handle technology. Did you save it? No. All right, so now I want to get back to them, right? Well, let's just turn our calculators off. Okay, we turn them off. Why won't mine? Maybe I can't really turn mine off. I don't know. Okay, pretend like we turned it off. All right, so now what we want to do is we want to find one, right? We want to open it. If we hit doc, oh no, I won't do that. If we're here, doc, and we want the file. So it's just like a computer, right? File, and we want to open a document. And then if you scroll down, you can probably see yours better than you can see mine. There's your FRQ1 and FRQ2 down at the bottom. So you treat it like, just like if you're in Windows. Yeah. Was that it? Was it right there? Shoot, thank you. Front My Documents. Where? I don't know. Oh. Maybe. I guess mine's just different. Oh, then My Documents is right there. Oh, that's where I am. Okay. I have a lot of other stuff in here for whatever reason. Mine's a little bit different. But did you see how to get back to them? And then you can switch back and forth from them. And then when you go back and forth, it will say, do you want to save this? If you did anything and it say yes, then you can go back and you don't have to restore everything, do that. And if you go from 1 to 2, if I'm in the FRQ1, I can store things in A, and FRQ2, I can store things in A, and they're not going to affect each other. Does that make sense? Okay. Maybe, but I don't know how, so we'll figure that out. Maybe, I don't know. All right, so I don't know what document I'm in, so I just want another new document. We don't want to, make sure you're not doing anything in FRQ 1 or 2 right now. Okay, so, oh my God. What is wrong with me? Okay, I'm creating another new one. So it just says doc up there, it doesn't say FRQ. And that's how you're going to know you're in the right one. It'll say FRQ1 or FRQ2 right here. Once you try to go to another one, it will say, I don't know how you save as. How do you save as? You know, like when you're in it, how do you just? Oh, it's under file. Okay, thank you. Oh, save as. Okay. Well, if you already have, we already have it named, so I would just hit save. Okay. And you could always, I mean, you can create your own, and that's what I was going to show y'all to do when you got into there. But because it's so new, I wanted you to have it. At least you can know how to find it. You can go back and forth with it too. All right, are we good? All right, so now I have another sheet. Oh, shoot. I printed them out. I didn't give it to you. Running out of time. That's okay. See, why do I do this to myself? I printed the dang things. I'm losing my mind, guys. Oh, here they are. Oh, to you? I asked if they would change your test. She said no, because if I do it for somebody, I have to do it for everybody. So you're taking chemistry tomorrow, which means next week, Monday or Wednesday, you are stuck here with me taking this test. Maybe you should learn to check your email and fill out things like you're supposed to. That's right. That's okay. I'll have pizza for you. All right. So here we are. I felt like yesterday, after we were done, I feel a little bit better now that Miss Bruce has talked you through it, but I felt like we might need to talk through a few more of these. I like this one too because it had some pictures that we didn't have to draw, where you can kind of visualize what we did with the Play-Doh, right? Okay, so to remind ourselves, if we want to find volume, what do we do? Area, we integrate area. Okay, so I have cross sections of the area taken perpendicular to the x-axis. Remember that means that's a dx. So I'm going to integrate from A to B the area of x dx. Right? If I have cross sections taken perpendicular to the y-axis, I'm going to integrate from A to B. A, and that y-axis, that's a dy. So that's A of y dy. Okay. We okay with all of that? All right, so let's do this first example. We won't do all, well, we don't have time to do them all anyway. All right, well, here it just says to set them up anyway. So we're going to set up the intervals needed to find the volume of the solid whose base is the area bounded by these graphs and whose cross sections are perpendicular to the x-axis. So that's a dx. So what is this one graph? What's that graph look like? It's a parabola, so it's going to look like this. And it's positive, so it's basically just your parent function, right? What does this graph look like? A line. But it's so I've got a negative slope, so it looks like this, and I have a +3 as a y-intercept, so it looks something like that. I don't have to be exact, right? And then this is my area under there that I'm going to integrate. So it tells me that I'm going to have rectangles of height of 4. So I can draw my little rectangle. Okay, and because that rectangle, well, I don't know what happened to my little square. Did you steal my square? Oh, it's over here. Got it. A square is a rectangle, right? So, and we're perpendicular to the x-axis, so it's going to look like this, which means that's why it looks like this, and then this part's standing up, right? So the height of 4, so this is 4, h equals 4. And then this part right here is this. And how do I find that? Exactly. Top function, which this one is the negative 2x plus 3. And this is the y equals x squared. So this side length right here is going to be the top, which is negative 2x plus 3, minus this one, which is x squared. So I'm going to have to integrate. Do I know my limits of integration? No, I've got to find them, right? Okay, but this is not a calculator question. So what am I going to do if I can't graph it on the calculator? Yeah, set them equal to each other. This is going to be my A, this is going to be my B. If it was a calculator question, we can find them on the calculator, but we don't need the calculator on this, so we need to know how to do it that way too. So that means I'm going to say up here, x squared is equal to negative 2x plus 3. So x squared plus 2x minus 3 equals 0. Super easy to factor. Negative 3, no, positive 3. I say it's easy, and then I'm going to do something stupid. X plus 3 and x minus 1. So that gives me x equals negative 3 and x equals 1. Okay. So I'm going from negative 3 to 1. What's the area formula for a rectangle? Base times height, right? And so they're calling this the height, this the base. Does it really matter? No. Okay, but we'll do this first. So the base is negative 2x plus 3 minus x squared times 4 dx. And remember, yesterday our height was 1, and I wrote it in there anyway, even though it really didn't affect anything, because we want to think about the fact that we're multiplying those two together. I totally would not. Well, oh, that's a very good question. I'm glad you asked that. Would you multiply? So if I said that this was not a calculator question, would I multiply them together before I integrated? I actually would not, but I would do something with that 4. What can I legally do with that 4? We can put it on the outside because it's a constant. It can go out here, so I can say 4 times the integral from negative 3 to 1 of, and then when I rewrite it, well, it doesn't even matter, never mind. Negative 2x plus 3 minus x squared dx. Okay. So you can bring the constant out front. If this was a calculator question, I wouldn't bother rewriting it. I would just leave it in there because we could multiply through and then still integrate, and there's nothing wrong with that, but that by hand, it does make it a little bit easier that way. Okay. Good question. What else you got? You good? All right, so let's do the semicircle. So the semicircle, which again, I only made small ones. I wasn't thinking right when I did this, and I should have made one big one and a bunch of small ones, but pretend like this is a little semicircle, looking like that, right? So it's going to go, look something like that. This right here is what I can find directly from my graph. That is the same as this. Would you agree? Yes. Okay, so, and that is what part of the circle? Diameter. Good job. Negative 2x plus 3 minus x squared. That's an equals, not a z. But what I really need here is the radius, right? So how do I find the radius? It's 1/2 of it. So 1/2 times negative 2x plus 3 minus x squared. You could. Depends on how you want to write it and what you want to do with it. All right, so what's the area formula for a circle? Pi r squared. Are we finding the area of the whole circle? Half of it. So I'm going to put 1/2 in front of it. Okay, so think what's the area of a circle and then go from there. So I already found my limits of integration. So I'm going to integrate again from negative 3 to 1. And I have 1/2 times pi times the radius, which is 1/2 times negative 2x plus 3 minus x squared. squared. Now pay attention to where your parentheses are and what you're doing. This whole thing right here is the radius, right? So this squared doesn't go on the outside of these parentheses, it goes right here. Yes. If they have something like this, where they're squaring something like this, is that going to be a calculator problem? Yeah, I mean, this one could totally be non-calculator, right? That's easy and fair, but this one, set up but don't solve anyway, okay. Yeah, so since it's set up and don't solve, I would stop here if that's what it's really asking you for. Don't bother doing that because you don't want to accidentally not write something correctly. Okay, we good?